Now, one of the things we wanted to talk about is architecture. Now, what we've seen in several manufacturing plants in our experience is an architecture similar to this. A company will purchase device drivers from a single company or from multiple companies to connect to the PLCs and pull out the tag data. They then purchase a data converter that will take that PLC tag data and convert it to a JSON message. Then a client is needed to basically take that PLC data and be a client to the message broker. So they install a message broker from another company to allow data to be brought in over PubSub and then broadcast out. And then to do anything with the data, they're writing custom code potentially to work with that data, or they're buying another vendor to do the integrations to possibly take that data, create a data model and integrate it to another cloud, or basically go from the message broker directly to the cloud with no control over how often that data is sent. So we've seen this architecture quite often. The biggest problem with this architecture that companies run into is, yes, the data flows, it works fine, but how do I scale this? How do I replicate this? Because you've got different vendors to provide this architecture, it gets difficult to replicate and change and adjust based on remote locations, and being able to do that without having to go to the plant and actually install this system or these systems on the plant level. So if you take a look at the Litmus Edge has a very similar architecture. However, all of that architecture is built into a single platform. So here we have our device hub where all the drivers live. This allows us to connect to all the devices on the shop floor. We then have a built-in message broker called Data Hub where all the data is being normalized and broadcast into this message broker that's built in. We also have a time series data storage included with that, so we're easily storing that data with a timestamp on it. Integrations are built in, flows allow you to work with the data, analytics is already built in, and we can also run the marketplace, which would be custom applications, for instance, such as machine learning or visualization tools or analytics or whatever you would like. So all of this is built into one platform, and based on our architecture, you can actually break these up if you wanted. You could have the device hub do the PLC connectivity in a set of multiple devices. You could have another Litmus Edge be the data hub or the message broker, and then multiple integrations, Litmus Edges as integrations or flows. So you could actually start architecting this however you want, because we can communicate from message broker to message broker, which allows you to be very flexible with your use cases and architecture to meet pretty much anybody's needs. We also have the features such as digital twins, where we can create a data model that can then be used with integrations to send to the cloud or other devices as well. The nice thing about having it all under one platform is now it does become scalable. So we can take our Litmus Edge Manager and create templates around all of the connectivity, flows, analytics, etc. Create those use cases, create a template, and then deploy those templates at scale, while also managing all the devices to make sure that the resources and licensing and everything else you need for the life cycle of an Edge platform is taken care of, and that's all done through the Litmus Edge Manager. This also helps with other things, not just scale, but for instance, if you look at the life cycle of machine learning, where you want to connect to the PLCs, get data, stream data to the cloud, where you can then start developing your machine learning model. So you develop your machine learning model here in the cloud that can then send data back to integrations to the Litmus Edge, where we can then display data for the operator to make that change, or close the loop back to the PLC, because it's all bi-directional communication. So you can close the loop with your machine learning. The next step on that machine learning path is going to be the deploying that machine learning model at the edge, because of either costs of the messages going up to run that, or compute power in the cloud, or just latency costs because of the timing between the data going to the cloud and back and making the round trip. So that data model, or that machine learning model, can then be pushed down to the edge and run in the marketplace here as a container, and have access to the data, so you can actually run that machine learning here at the edge. While that's happening, you can always improve it, and you follow that life cycle, that ML ops application of basically gathering data, creating your model, deploying the model, testing the model, deploying the model, and closing that loop, and continuing to improve that model at the edge. So that's another benefit of being able to do that all at the edge and be able to manage it from the Litmus Edge Manager. What we have here is the Litmus Edge platform. This is a platform that will run on the shop floor in a factory and can be run as a virtual machine, a bare metal installation, or as a container. You'll see here that I'm using a browser, and that is because the Litmus Edge platform is using a modern web stack to do all the interface to the device, so no need to download anything on your machine. Just any modern web browser will be able to connect. The user interface here we can see has the 5 steps for digital transformation. The first thing to take a look at is going to be the device hub. Device hub is where we actually do the connections to the PLCs and bring in the data, which would be referred to as tags in the system. So let's take a look. We click on Device Hub, you'll see there's already multiple PLCs connected. To do the connection is very simple. We click on the plus, and we have these drivers built into the system. There's over 270 drivers that are already built in. There's no need to buy them or purchase them separately. All the drivers come with the system. To add a new driver, you basically just click on the driver you want, choose the PLC type that you have. I'll choose Rockwell Ethernet free tag for now. All we need to do is name that and set the IP address. We default the port and the slot number for you, and that allows you to make the connection to the PLC. We already have some PLCs connected here. I can just show you the configuration. What you'll also notice here is we've added what we call metadata to the PLC. So at the device level, I can actually add metadata to that device. This could be things such as location, type of machine, maintenance schedules, etc. So just data that you can add to this that will then be used further down the process as we start getting into the processing of the data and the analyzing of the data. We can also check this box here for Enable Data Store. That will allow us to store data from the PLC directly to an inbuilt time series database that is on the platform. And that allows you to store that data and be able to use it for future evaluations, such as in a BI tool looking at time series data. Once the connection is made, you can then add to the tags. Tags are generated by going to tags. There are multiple ways of ingesting the tags. You can hit the plus sign here. You can add one tag at a time. You can upload a CSV template, and some devices actually allow you to browse tags such as OPC UA, and we can then bring that in. You can see your tags here, and I can just check a box and bring all those tags into the system. Once those tags are in, we're going to normalize that data. We're going to convert all of the data into a data model that is based on a JSON object, and we'll show you that in the next step. Devices and pulled out the data. What we can do is start working with that data. So we're going to go to Analytics. Analytics here. And what this is we're going to subscribe to that topic because everything now has a topic associated with it. So all my PLC tags have a topic. I'm going to take that data and then I can run a KPI or analytic on it. In this case, there's an uptime, downtime. There's also moving average, rounding, anomaly detection, and others, which we'll show you shortly. Once that's KPI is calculated, we can then output it back to the message broker to be used by other services, or we can store it in a time series database. Now, the first thing I want to do is actually show the data output. So we're not just outputting the PLC value. What we're doing is we're building a JSON model that includes not just the value, but the tag name, the device name, the metadata that we referred to earlier, the value, a timestamp, a description, data type, etc. So we've already created a data model right out of the box with the PLC data. To then run a KPI on it, what we can do is actually transform that data. So we'll take that raw PLC data and we'll convert it into an uptime downtime. Here you'll see that we're calculating and transforming the data into asset utilization, total amount of downtime, previous downtime timestamp, the timestamp, total time that it's been running, and uptime. All those being calculated in seconds. Once that value is calculated, we can then use that data back into the message broker to be used by other services, or we can store that data in the time series database. To set up an uptime downtime, for example, we can go in here, and the idea is to use no code to set these up. You just select the units of measure you want, in this case seconds, and then the rule for what is considered uptime or downtime. To do something like a moving average, where we can just calculate the moving average of a value, very similar. We're going to edit that, just pick your sample size and set up your processing type. That's all you need to do to calculate that. And then, for instance, anomaly detection, we can actually set up anomaly detection, which will be based on statistical processing, where it will calculate the lower limit, upper limit, moving average, standard deviation, etc., and do that calculation again with no code. Just set up the rules here, and all you need to do is set up the number of deviations and the sample size that you want to set. As you can see here, we're doing a 6 sigma calculation on 100 samples. Some of the other processes that are available here is we can just build a flow here. So I'll start with adding a new topic here, a new data flow, excuse me, and we'll just pick a value such as this. We're going to change this to current, and we click next here, and you'll see that we've got all of these analytics already built. So you can just hover over them to determine what these are. We already talked about the anomaly detection, but you can do things like manufacturing counter or statistical prediction based on an FFT calculation. You can run tensor flow models here, so you can do machine learning here. There's also linear predictions, moving minimums, moving maximums, etc. So all these are available. Again, no code needed. You can also write your own expression or write your own script if you would like. Once you choose your KPI, you can then go and tell the data where it wants to be set, which would be the data hub published back to that message broker or to that database of time series data, or we can send it to both. And you can see here we can build some complex calculations here. So I can, for example, calculate OEE, where we can join multiple applications and multiple KPIs together to actually create OEE data. Another useful tool in the Litmus Edge platform is flows. This is based on a Node-RED language from IBM and allows for a visual programming language, so you can actually build whatever you would like in that. Notice here we've actually got 4 instances of Node-RED, or 4 instances of flow running. We're going to log in, again, not leaving the browser, just using the same browser. You'll notice here that we've got a flow that's built in here that is used for monitoring downtime. So what we're doing here is we've created a flow that's capturing the is running data. That's a tag on all the PLCs, and then once a downtime occurs, we're going to record the start time and stop time of that downtime and store that into a database. Is after we've transformed the data into the format we want, we can then integrate that with other cloud systems. So I can just, or other databases, so I can go right to integrations and actually show that we've got a connected data here. We're connected to our Litmus Edge Manager, MQTT broker, and sending data there. Again, to set up an integration, very easy. All these integrations are included. So we've got AMQP, cloud hypervisors, time series databases, SQL and NoSQL databases, other message brokers like Kafka, etc. All these are included with the system, and the idea is to make it quite simple to configure. For example, to set up an MQTT broker, we're adding the certificates, the information you would need to make that connection. Once the connection is made, you can drill down into that. You can then actually send data up. So very easy to set up the data. This includes inbound and outbound data, so we can not just send data, we can also bring data back in. So this helps with the machine learning ML ops, where you can actually send data to the cloud, develop your model, and then bring the data back down. Built into the integrations on all of these are store and forward. So if you lose any connection to the endpoint data repository, we will store that data in the Litmus Edge based on the resources available, and then forward that data on once it is reconnected. That is all automatic out of the box. One of the other features of the Litmus Edge is the ability to create an OPC UA server. So you can see here that we can actually configure a server and import the PLC data. So we can click a button here and actually import all the data from the device hub and create our own OPC UA server here. And you can see that all the data is there. So now any OPC UA client can connect to us and we can serve that data up. You can also create your own custom OPC UA server by adding analyzed data to it. So for instance, if you calculated OEE at the edge, you can create a tag called OEE and expose that as OPC UA to be used by other systems such as the SCADA and actually do the calculations here locally at the edge. The connections to the OPC UA server include all the standard security policies that are available, so require or not require certificates, usernames, or passwords. And you could configure the port and IP address of the OPC UA server. One of the things that the Litmus Edge platform does is allow you to run your own applications. So built into the Edge platform is a Docker engine that allows you to run whatever application in whatever language you'd like. So this can be used for something like a BI tool, a small database, machine learning applications, etc. So this allows you to actually run those custom applications here at the Edge. So to actually go take a look at that, we'll click on Applications. We have a dashboard here on what the system looks like. We can actually connect to a marketplace. This is where you can build your own marketplace of applications and allow users to download them, similar to downloading an app on a smartphone. And you can actually see the containers that are running here. You'll see all these different containers that are running. So the PLCs are actually run as simulators. I've also got a SQL database here running, as well as a Grafana running as a container. So you can actually run containers right here from the Edge or be able to deploy that at scale using the Litmus Edge Manager. New features of the Litmus Edge is the digital twin feature, the ability to create your own digital twin. So the first part of the digital twin or building of the data model is to start with the model instance. So this would be the template of the model. So for instance, let's pick this robot arm. The first step is you can create the static attributes of this robot. So this would be location, type, manufacturer, etc. Things in the model that you wouldn't necessarily change all the time. You can then add the dynamic attributes. So this would be the data that is changing within the model. So you can actually start creating your tags from your PLC or other systems like ERP or MES systems and include that data here. You can then create a hierarchy, so you can create whatever hierarchy you want and whatever model you like just by simply dragging and dropping the tags that you created in the static and dynamic attributes. So we can create this model here, this simple one here, for example. We go back to digital twins and you can then create the instance of that. So this would be deploying an instance of that model simply by clicking on the plus, choosing your model, naming it, and the interval for the polling. So let's take a look at a digital twin that's already created. We will click on here. You can see that here are the static attributes. I can go in and change these as I want. So I can just change this and save it, that will be the new static attribute. The dynamic attributes are then mapped to anything that has a topic associated with it, so any PLC tag or other data that you have sent into the message broker. So this could include analyzed data or data from other systems. Once you have that mapped, you can then go to data access, subscribe to that data model, and you'll actually see what your data model that you've created looks like. So you can see here that we're actually pulling data here. Not much is changing, but you can see actually the timestamp is changing so that it is updating all the time. Also note that we have this as a topic. So since this is a topic, this data model is already being sent to the message broker within the system. So if I would like to further work with this data model, I can basically just copy that topic and use integrations or in flows, or actually use this for another topic within a larger model. So each of the models can then inherit data from other models. So I can then create models around individual assets and then bring those all into a plant model and use the models that are created here. So as you create larger models, you can inherit the other ones. And once you have that model made, you can obviously replicate it many times. This is also, you're also able to do this from the Litmus Edge Manager, so you can basically replicate this at scale. Now that we've taken our Litmus Edge, connected it to PLCs, pulled out data, transformed it, created workflows, analytics, etc., what we can do with that is we can actually scale that. So how we do that is we use our other product called Litmus Edge Manager. Litmus Edge Manager can run in the cloud or in a company's data center, wherever they like, and you can then start to organize your edge deployments. So the first level is company. This could be country or business unit or plant, whatever you want to name it. You can then drill down into that and then create a subcategory we call projects, but this could be plant name or line 1, line 2, etc. We'll drill into that use case demo. Here you start to see actually a dashboard of all the devices that are connected. So you can see how the systems are doing. You can actually look at the CPU devices and see how the CPU and memory and the devices are working themselves. And you can also look at alerts. So it allows you to start to gather information on the data and do a health check on the devices. You can also check on the licenses, what's expiring, what has expired. You can then see the devices that are connected. You'll see that we've got multiple devices here. These 3 are online right now. But the scalability is what we want to talk about here. Once the device is connected, what we can do is actually go to templates, and you can actually pull in a template from a device from here, or you go back to the Litmus Edge here and actually create a template from here from a file. So you can choose what you'd like to connect or create a template around. So that could be your cloud connectors, it could be your PLC types, it could be your digital twin, your flows, your analytics, etc. So you can create a template around that and use that file and upload it here, or you can create it right from the device. Just choose your device that you want to create a template from, and then choose the templates you want. Once you have that template made, you can then see that template here and go deploy that. So I can just click on the 3 dots, apply the template, and it will basically, I can select the devices I want to send it to and deploy that template down to those devices. So it allows me to easily scale a use case based on how you want to organize your templates. You can also do the same with applications. So I can actually deploy the application. So if I can create a custom machine learning algorithm, for instance, or a visualization screen, I can basically have that image stored here and deploy that down to the device. Again, very simple to do that. Click on the 3 dots, launch the app, choose the device you want to send it to. You can then go change any of the settings you want to and get to the point where you actually then deploy the device down at the edge, and it makes it easy for you to actually control the applications that are running at the edge, all from a local instance. You can also you have remote access to the devices from here to help you scale, update software, monitor events and incidents as well, and create alerts around data or events happening at the edge. Again, this tool allows you to not only manage the tool or manage the Litmus edges you have deployed, but also helps you deploy at scale and add new features during the life cycle of the product.
Earlier this year, Litmus launched Central Portal, which allows users to accelerate their journey for Industry 4.0. Central Portal consists of two main parts: solutions and hosted sandboxes. A user can get started with Industry 4.0 by deploying their own version of hosted sandbox at Central Portal. The sandbox is a full-fledged product which is available for 15 days, where they can get the latest and greatest features that Litmus offers available configuration or setup. The second part of solution covers different ready solution tools. An example, we have a CVE advisory application that runs on Litmus Edge. It monitors the metadata which is part of the devices which are added to Litmus Edge and provides you the vulnerability for those systems. As you can see here, there are various industrial systems which are talking to Litmus Edge, and it gives you the vulnerabilities along with their severity and details listed in the application. The application works without any internet access, and it's up to date with the latest NIST database which is published every day. Second solution to go through is Sparkplug, which allows user to categorize their data and provide a structure which can be used to connect to different host applications. Is compatible with all the Sparkplug B compliance. Litmus, being a part of Eclipse Foundation, also published Sparkplug B solution, which makes Litmus 100% Sparkplug compliant product. As you can see in the application, different PLC devices are sending data over Sparkplug B. If I connect to the broker, you would see Sparkplug messages being received on the broker, which is categorized as per the specification. Other solutions includes Production Record DB that allows user to enable use cases like track and trace, downtime reporting, scrap reporting, etc. Solution has a simple GUI which allows user to just provide their configurations for the server and would take care of the schema and storing and data management of the data. Litmus would be adding more and more solutions in different categories every month, which would enable small scale to grow to implement Industry 4.0 journey without the need of any system integration. Central Portal also offers a way for product management where they can download the different offerings of Litmus products. Central Portal also offers product management, license management, team management, and manage your subscriptions. A user can get started with Central Portal using a self-paced video tutorials available on YouTube. Thanks a lot.